Hi, today I want to talk about the ESP32 and building a small Bluetooth controlled robot. Or in my case, I use a small Buggy that I bought as a kit, so I don't have to build all the parts. And this kit already have a dual H-bridge controller and the wheels and also the motors inside and so on. So I only need to add the ESP32 to this kit. And before we go to the details and the software and so on, I show you how I wired up the ESP32 to the H-bridge controller and to the motors. So let us start with the ground wire, and then I connect 4 GPIO pins to the 4 input lines of the small module. So I take GPIO pin 23, 22, 19 and 18 and wire them to the input 1, 2, 3, 4. Then I use the 5-volt rail for the logic level voltage and also as the power rail for the motors. And last but not least, I wire the motors. They go first to the output A, and also the motor B goes to the output B. So let us have a brief look to the datasheet of the L298 dual full bridge driver for the motors. And this block diagram shows how it works. So we have the supply rail for the logic level and the supply rails for the motors. And we have 4 inputs and also an enable pin for the inputs. And if we switch on input 1, then one of the H-bridge controlled drivers put out the rails to the motor. And if we use input 1, then we go one direction to the motor, and if we use input 2, then the whole logic is switched around and the motor turns in reverse. And the same for the second motor. If we use input 3 or 4, then we switch the motor B in one direction or in the other direction. And we can have a deeper look, so we can use power supply up to 50 volts maximum ratings and a logic supply voltage up to 7 volts, but I think this is the typical configuration. So typical we use 5 volt for the logic level and up to 46 volts typical or maximum. And for the input voltages we can use something above 2.3 volts, so we fit with our 3.3 volt level inside the high and also the low level while using the ESP32. So that's all we need to know about the L298. Sure, on our module there are some more circuitry because we need also for the motors some protection diodes and so on to prevent some back EMF spikes. And before we dive deeper in the software, I use my mobile phone with the NAF Toolbox application as a Bluetooth client, and I configure some keypad pins so I can control the Bluetooth UART software on my ESP32. And this is the Arduino software. I use the UART BLE example from Neil Colburn, and this is ported by Evandro Copercini, if I spell this correct, and I just added some additional lines. So this is the lines I added for the motor GPIO pins. So this is for forwarding the first motor and reversing the first motor, and the second motor the same, forward and reverse. So we use 4 GPIO pins, and then this is the whole UART example with the service ID defined by Nordic Semiconductor. So this uses the Nordic UART service UUID, and we have 2 characteristics in receiving characteristic. With this UUID, it's nearly the same, only this number is changed. And we have a second characteristic for transmitting, and this is the number 3. And then I insert 4 small functions. This is for the motor driving forward and wheeling down, and I steer both of the motors in forward direction and then switches all the motors off. And the same with the reverse direction. All motors 1 and 2 goes in reverse, and then we switch it off after some delay. And left is we steer the one motor in the reverse direction and the other motor in forward direction, so we can turn the whole buggy left. And the same, if we do it in reverse, then we steer the buggy right. And then we have some services callback that's only using if we want to decide if our Bluetooth service is connected or disconnected. And then this is the whole centerpiece of the software. So if we receive a message that has the name up, then we steer the motor up. And if we get a message down, then we steer the motor down. And the same for left and right. And that's it, nearly. So, and I have also inserted a callback for the descriptor, but this is not necessary. This is just a play around with another project. So, and this is also some additional lines. When we set up, we also have to put all the 4 GPIO pins in output mode for the 4 motor pins. And that's it. And now just a brief look how I prepare the NF Toolbox application to steer the Bluetooth commands over Bluetooth low energy. So I open the tool, go to UART, and then we can edit the keys on our keypad, and you can use any symbol you like, and just I use the up, left, right and down command, and then I go to done, and then I have configured my keypad. And then after preparing the ESP32 Bluetooth software, you can connect to your device and just use the buttons to steer the motors. Now just a practical demo. You see my bench with a small buggy, and I show you my mobile phone and how to configure the NAF Toolbox application. And after connecting to the ESP32, then we can just play around with the buggy and the motors. So thanks for watching today, and I hope you find this useful and learn something. So please share, like and write some comments. And if you like the channel, please subscribe, and I wish you a nice day. See you next time, and bye bye.